So we are putting together a environmental footprint, a life cycle assessment of Spanish pistachio production. So the carbon footprint is one part of a life cycle assessment, which consists of many different environmental footprints in different impact areas. The carbon footprint is of great interest because it relates directly to climate change, as many people probably already know. So when we look at any industrial system, agriculture or manufacturing or construction, we have the ability to measure and model the environmental effects, the impacts, and compare against the benefits that we receive. So in an agricultural system, this is interesting and more complex because not only are we using fuel and machinery releasing greenhouse gases from fossil fuels, but we also have all these trees that are drawing down CO2, carbon dioxide from the atmosphere every year in photosynthesis and storing it in the woody biomass as well as in the soils of the orchard. So when we construct a carbon footprint of an agricultural system, especially a long-lived, maybe 100 years lifespan in a pistachio orchard, that is CO2 that is held out of the atmosphere for the lifespan of the orchard. We quantify that and measure it as a benefit to be compared with the impacts of the system. This should be important to growers and to everybody in society because agricultural systems like this, especially the perennial crops, have a great potential to help mitigate climate change if managed appropriately and monitored and measured for carbon storage in soil and standing biomass. Yeah, the most important factors in the release of greenhouse gases are energy use, and that is connected to irrigation, especially when we have groundwater being pumped. It requires a lot of energy. Fuel use in agricultural equipment, and in fertilizer and pesticide production, the energy and fuel that's used to produce these materials and transport them to the orchard. All of these have a carbon footprint that can be measured and quantified. And this is subtracted from the benefits achieved from photosynthesis, from carbon storage by the plants and soil. Yeah, I think there is a measurable benefit in addition to other agricultural systems. With pistachios, especially any perennial system that stays in the ground for multiple years without tillage, without digging the soil, it increases the benefit of carbon storage in soil. Because when you dig, you expose to oxygen and release the stored carbon to the atmosphere. So when we have these perennial trees, the pistachio industry, as much as it may replace cereals or other annual crops, has the potential to store more carbon and have a greater environmental benefit over an annual cropping system. Yeah, so this is part of the reason that my job is interesting and fun, because there's many problems to solve when you harmonize two different analyses, two different types of systems. So the first thing we want to do is make sure that we use the same models and the same types of data to compare the systems. Which is what we're doing here, trying to make sure we collect the data with the same methods, right? And then, the comparison between two regions and two countries is not just to say, it's not to say this one is better, one is more sustainable. It's to show where, in what areas is sustainability achieved? Where are we reducing environmental impacts, and what practices are associated with environmental benefits, so that the two growing regions can learn from each other and we can have overall a better, because storing carbon here is wonderful, but the greenhouse gas impacts affect everybody equally around the world. So we need to learn the lessons from every country, every region. Carbon footprints, environmental footprints, are strongly correlated with resource use efficiency. And every farmer already tries to do their best to be most efficient because that saves them money. So using less fertilizer, precision agriculture techniques, you use fertilizer, use water as efficiently as possible, you're already doing a great deal to reduce your environmental impacts. In orchards in particular, one of the best ways to increase soil carbon and improve carbon storage and reduce greenhouse gas impacts is to return biomass to the soil. And this can be prunings, put on the ground, shredded, and it can be shells and hulls sent back from post-harvest processing. And we've seen some real quantifiable soil carbon benefits with that sort of return of biomass to the soil. Pistachios are an excellent example, and I think a difference I've seen so far in this visit to Spain with other perennial crops is, olives and almonds and others, is that the orchards are managed for very long lifespans. For California production, the tendency is to drive very, very high intensity production and shorten the lifespan of the orchard. And storing that carbon, the measurement and quantification is, the same methodology no matter how long, 1 year or 1,000 years, we can use the same methods to quantify the benefit of stored carbon. However, when it comes to awarding credits, there's a big question about the length, the residence time. And when you have a system, perennial or annual, where the lifespan is less than 100 years, the rule from the IPCC, for general accepted rule, is that we don't count that. It's temporary carbon storage, not permanent. But the beauty of the pistachio system in Spain is that we intend to keep it in the ground producing for 100 years or more. And when that is the baseline assumption, when we can assume that this is the expected lifespan of the system, then it becomes more simple to simply include the calculated carbon storage over that time period and compare it against the emissions over the same time period. So the energy, water, and climate nexus is a major area of research in all industrial systems, and in the study of industrial agroecology, which is sort of a name for what I do. The irrigation practices, they drive energy use, and that can be reduced by using solar panels for pumping or renewable energy. The energy use from lifting water against gravity out of aquifers, or any pumping system pressurization. These are all producing greenhouse gas impacts relative to the amount of fossil energy being used. Irrigation practice also affects soil emissions. The wet-dry cycle in the soils can promote the release of nitrous oxide with the use of fertilizer. It's a form of nitrogen escaping from the soil that is a powerful greenhouse gas. So more precision, efficient irrigation use, delivering water where water is needed, can reduce that nitrous oxide emissions. This is something that we calculate using a biogeochemical model that accounts for soils, for irrigation practice, for rainfall, temperature, and climate, as well as cropping systems and tillage. One of the biggest surprises, I'll say there's good surprises and bad surprises. In California, for example, many growers have adopted solar panels, solar panel for irrigation pumping, which does have a benefit in terms of greenhouse gas emissions and energy use. However, the benefit is less and less every year because the electricity grid, the base for which we're comparing solar panels, becomes, this is a good thing, but it becomes decarbonized over time in California. So when you replace electricity that is primarily fossil fuel based with solar panels, you get a very big benefit. When you replace electricity that is renewable energy or renewable systems, the benefit is less. And many growers that we've talked to, commodity boards and funders, have been shocked at how how little of a benefit they get from replacing solar panels at this time, because the grid has already decarbonized a great deal. 20 years ago, when fossil fuels dominated the electricity grid, the benefit was much greater. So that is a sort of unpleasant surprise that we've had. And that may be true in Spain. I think Spain already uses more renewable energy than we do in California. So the marginal benefit of adding one more solar panel becomes less and less as time goes by. But that is actually a good thing in the big picture, because that means our overall national carbon footprints are getting lower. A pleasant surprise would be the sheer amount of carbon that comes off the orchard in the form of prunings, shells, and hulls. This annual carbon production that is typically lost, is composted, goes to animal feed maybe, or to other use, or burned for energy. The amount of carbon is more each year, or the annual amount is far more than the total amount over the lifespan of the orchard. So the lesson there is, it's surprising how much carbon that represents, shells and hulls and prunings. If we can find a way to store it, return to soils, create biochar, even to put into building materials, composite building materials, that for long-term carbon storage, the benefit of the orchard can increase by maybe order of magnitude. I think the experience that we have with the California, with US export crops, is that the growers don't see any difference what their carbon footprint is at this time, but the wholesale buyers, Walmart, Costco, I don't know if you know these names, but and markets like the European market, Australian market, Asian markets, they want to see that. And what happens is they are the ones driving this research. They're funding it. They're causing the commodity boards to invest in carbon footprinting research, right? And so the cost of or the value of yield of the commodities produced may not change directly related to the carbon footprints, but the interest of markets may change. European buyers may say, we don't want California pistachio because they don't do as much for the environment. They don't reduce greenhouse gases as much as Spanish pistachio, for example. That's not necessarily true, but that may be one thing to think about. The other way that pricing may change, profits may change, because there can be subsidies from the EU, the European Union government may support sustainability, including reduced carbon, but also exploring ways for growers to get direct access to voluntary carbon markets by adopting new practices, additional practices like returning shells to the orchard soils. This can be a way that growers can get a payout, a new revenue stream for their systems that can increase their profitability even if the price of the commodity does not change. I would say I have so much appreciation for how enthusiastic the Spanish growers have been in helping us collect data, in providing information about their orchards. We have had so many responses for surveys, and I appreciate it very much. And I truly hope that the work that we're doing can be of interest to the growers and provide some benefit and help them get access to new environmental benefit-based revenue streams and subsidies and everything that helps keep orchards in the ground and keep agriculture thriving in Spain and everywhere.